Chair of the Department of Philosophy at the University of Miami, where I had the pleasure of attending a graduate conference on epistemic relativism 2 years ago. His work focuses on philosophy of science, philosophy of mathematics, and philosophy of logic. He's interested in developing an empiricist view about science that is compatible with a nominalist view about mathematics and logic. He's going to talk to us today about pluralism and relativism, logic, mathematics, and metaphysics.
Well, thanks for the introduction. I'd like also to thank the invitation. It's always a treat to be back to Germany, and especially to talk about these cool things. So the talk today is an attempt at identifying to what extent I'm a relativist, to what extent I'm not, right? I've been sort of, in a way, similar to Marx, well, sort of puzzling over and sympathetic with certain features about relativism, but a little cautious on the other hand. So this talk gave me the opportunity to try to think through where I stand, right? So, and to be specific, instead of just discussing pluralism and relativism in general, I'm going to focus in particular on pluralism and relativism about logic, about mathematics, and about metaphysics. And the goal will be to try to identify where it's okay to be a pluralist but not a relativist, and when it's okay to be both, right? Of course, pluralism and relativism are connected but should be distinguished, right? So both, I think, can be thought of as broad frameworks, right, for the interpretation of certain domains. And as well known, of course, there are different kinds of pluralism and relativism, cognitive, ontological, ethical. So for the purpose today, I'm going to focus on, as I mentioned, logic, mathematics, and metaphysics, and trying to carve out there some story. So first, I think it's more or less clear that relativism seems to require pluralism. And without a variety of alternatives in principle equally adequate, a relativist stance cannot get off the ground. Pluralism, in turn, does not require relativism. It posits a plurality of alternatives, but it's not committed to their equal adequacy or acceptability. Right? That's an additional requirement, which is sometimes contested. Thus, not only is relativism stronger than pluralism, but it's also more controversial. So far, I think there is nothing here that is controversial about that. And what I want to do is to try to identify the scope of relativism, right? So, and focusing on these three areas I mentioned. So what sense of relativism do I have in mind here? So what I have in mind is the following, right? Relativism about a certain domain is the view according to which there is a plurality of different approaches about that domain, which are equally adequate, and there is no suitable, i.e. non-question begging, standard to adjudicate between them, right? So on the relativist toolbox, we're going to find pluralism, right, as one feature of the view, what we can call an equipollence, right, that those views are equally adequate, and some form of incommensurability, right, that there's no common standard of adjudication between the rival views. And if it's the incommensurability bit that makes relativism, in the eyes of the critics, problematic, right? Because, oh, come on, how can you have all these different alternatives being just as good, or there's no standard to evaluate between them? Now, the pluralist picture, in the strict sense, all it has is just this plurality of views in the domain, right? But you can think about a little stronger form of pluralism, right, that recognize the plurality but insists on the equal adequacy of them. Right? That's a little more than just straightforward pluralism, right? It's called strong pluralism. Right? Or you can even go a little further and you have a super strong pluralism. Right? The different but equally adequate approaches about the domain involve concepts that are referentially indeterminate, right, but which do not lead to incommensurability. Right? So I'm trying to regiment in what sense I'm thinking about these things, right? So, and the thought is, well, it seems to me the pluralism is slightly weaker than relativism, right? So even the super strong pluralism that entertained referential indeterminacy of some concepts, still not quite there with the incommensurability bit. So we find here on this toolbox of the pluralist side, pluralism, equipollence, right? The views are equally adequate, and referential indeterminacy. Right, so I think that the key difference between the pluralism and relativism is on that notion of incommensurability. So that's how I'm, for the purpose of this talk, that's how I'm thinking about the debate. So what I'm going to go over now is discussions about logical pluralism, mathematical pluralism, and metaphysical pluralism, and seeing for each of those, I'm actually sympathetic with pluralism for all of those things, right? The question is, how about relativism? For which of those am I sympathetic or not, right? So we start with logical pluralism, right? So the idea of the logical pluralism here is that there is a single concept of logical consequence, but different logics that satisfy the concept. So there is a plurality of logics, although they can be brought together under a single notion of logical consequence. Which notion is that? Well, I think actually it's a modal notion, right? B follows logically from A if and only if the conjunction of A and the negation of B is not possible. So it's a modal notion. And of course, I think we have here a primitive concept of possibility, a logical consistency, right? Which of course is not going to be characterized in terms of possible worlds and all that stuff. We have a better grip on the notion of consequence than we do on worlds anyway. Now, depending on the particular domains that we consider, different logics are characterized. I'm going to say a little more about domains in a minute, but the thought here will be the following. If you have complete and consistent domains, you get classical logic. If you have incomplete and consistent domains, you have some constructive logic. If you have complete and inconsistent domains, you have paraconsistent logics. Right? So in a way, you generate different logics out of a single notion of consequence by changing what are the kinds of domains that you are considering. Right? Now, Beale and Russell, in their book on logical pluralism, they do something similar, but they adopt a kind of model theoretic version. Right? So the notion of validity, rather than being the modal one, they specify in terms of cases. They say something is a logical consequence if and only if every case in which the premises are true, the conclusion is true. And then they change the notion of cases, right? But I think they run into trouble because then they cannot ever quantify over all cases. Because if you quantify over all cases, you get no logical nihilism. Because then there is no structure or no single cases that actually capture all the consequences. So always you had to be restricted to a particular pre-select set of cases. The modal conception doesn't have that kind of problem because we're not quantifying over cases, right? We're just considering directly what are the relevant domains that you get. So it's a form of logical pluralism by domains rather than cases. But then what exactly are domains, right? So here we are, back again to domains, right? And of course, domains, I fully agree. I don't think domains are sets, and they should not be thought of sets. That would be a mistake. And think of them, I'm going to leave the notion of domain, intentionally somewhat vague, right? In part because I think we're going to grapple with the details in a sort of case-by-case basis, right? But think of them as sort of context of investigation about which inferences are drawn, right? Suppose that you're interested in making sense of constructive features of mathematical practice, right? So if that's what you're trying to do, then obviously classical logic would be inadequate for these tasks, right? Since it allows one to infer the existence of certain objects, say particular functions, given the inconsistency of denying their existence, despite the fact that it's not determined how to construct such objects, right? So you lose exactly the kind of constructive features if you have classical logic in the background, right? So if your domain is such that you're trying to make sense of those constructive features of mathematical practice, well then classical logic is not your best option to go. A constructive logic, however, that does not allow for this form of inference to go through would be a much better option, right? So what we have so now we're going to go over this conception of logical pluralism and consider each of the components of the pluralist toolbox, right? Pluralism is the first one, right? So the pluralism here emerges from the diversity of domains a logic can be applied to, right? So in addition to classical constructive and paraconsistent logics, which I mentioned, there are of course many other logics that, in fact infinitely many, that you can generate out of this, right? So you can talk about temporal logics, right, where the domains are going to involve temporal phenomena. You can talk about epistemic logics, domains in which epistemic operators are used, quantum logics, domains involving quantum phenomena. I'm going to talk a little bit more about that in a minute. Schrödinger logics, domains involving objects that lack well-defined identity conditions. Non-adjunctive logics, domains involving compartmentalized units, then you don't want to bring them together, so you don't adjunct. And off you go, right? In fact, there is not a single law from classical logic that has not been challenged by some non-classical logic in some domain or another. Right? And I think that should give us some reason to think that, well, maybe there is indeed, for good reason, the plurality of logics going on. But not only a plurality, you also get equipollence. Right? Given a domain, there are always several logics appropriate for that domain. So after all, given any finite string of reasoning, if it contains a valid piece of reasoning, there is always more than one logic that validates that reasoning. Right? For example, if you're dealing in a consistent context, classical logic and paraconsistent logics are going to coincide. Right? They validate exactly the same inferences in a consistent domain. So then any string of reasoning in a consistent context that is valid according to classical logic is also valid according to paraconsistent logic. So you cannot tell which logic you're using, right? Either one are going to agree on that. Moreover, such a string of reasoning is also valid according to infinitely many paraconsistent logics, because there are infinitely many of them. So there are always, you can never tell which logic you're using, right, in effect, right? That's because there will be several that, given the domain at hand, they're going to do the trick, right? Now, you may say, well, let's extend then the strings of reasoning, right? Then, of course, some logics may fail to validate these new inferences. So they may, okay, now we rule out some of them. But several is still going to validate the inferences in question. So it's always you're going to get others that would be appropriate. So not only is there a plurality of logics given a plurality of domains, there is a plurality of logics within a given domain. Right? So it's a robust form of pluralism there. And these logics will be equipollent, right? Will be equally adequate to sanction the inferences within that domain. Suppose that an initially consistent domain is extended in such a way that it later involves a contradiction, right, of the form A and not A. And that a sentence P is not derivable in that domain. Suppose that that's what happens. So you stumble into an inconsistency when you extended the domain. But not everything is derivable, right? So in this case, classical logic is no longer adequate as a logic for that domain, since the domain violates explosion, right? In classical logic, from a contradiction, everything follows. That's just being violated. So in that case, you say, well, okay, so classical logic is probably not the appropriate case here. So here's an interesting case to illustrate that, the Azandi, right? So when Evans Pritchard was studying, the Azandi were a group of people who lived in between the Congo and Sudan, right? And Evans Pritchard went there to study, as part of his work as an anthropologist. And they had a very elaborate system about, a sort of a priest that was going to adjudicate in some complicated cases, right? And if you thought that life is going not the way you thought it should be, things are falling apart and you're running into all kinds of trouble, you can charge someone as being a witch. If you think that, oh, there was that person that made something here that's messing it up. And the stakes are high, because then the priest would decide whether that person was or was not a witch. And if it was decided that it was a witch, you can go ahead and kill the person, right? All right, so, and there is a complicated procedure to decide whether it's a witch or not. And at one point it became clear to Evans Pritchard that the procedure was inconsistent, right? And he pointed out to the priest, he said, look, this is inconsistent, right? Isn't that a problem? And the priest looked and said, yeah, what's the problem with that, right? So he acknowledged that they have inconsistent beliefs. They did not derive everything. They didn't say everyone is a witch or no one is a witch, right? But it was inconsistent, right? So that's one situation, right? In fact, this is an interesting case. Charity here will force you to attribute inconsistent beliefs to them, right? If you make their beliefs consistent, you're actually going to lose their content. So you need some pluralism here to make sense of what's going on there. Now, in this case, involving classical and paraconsistent logics, which concept of negation is at issue, right? So we have the pluralism part, we saw the equivalence, now the third component, the referential indeterminacy, right? So now think about the notion of negation, and you're trying to figure out whether you're using classical logic in the context or a paraconsistent one, right? So which notion of negation is at issue? Now, in a consistent domain, classical and paraconsistent negations are going to validate precisely the same inferences. So which of these negations are we referring to when we refer to negation in such a consistent domain? The negation is not referentially determined, since in the sense of the extension of it, right? It's not referentially determined, since in this domain, a consistent one, the logics are equally adequate. Similarly, in domains that do not involve infinities, constructive logics and classical logic converge in the way they sanction inferences involving disjunction and negation, right? Excluded middle, for example, would hold. So the thought is, how can you tell, right? What is the logical constant that is being used, right? And the point here will be, well, you have a pluralism and you have, in effect, a form of referential indeterminacy about a very logical constants at issue. So in these finite domains, are we referring to classical negation or classical disjunction, or are we doing a constructivist one? They're going to generate exactly the same results. Since in these domains not involving inconsistencies, these connectives have the same logical properties, they satisfy the same logical principles, it's unclear how to indicate which connective, the classical or the constructivist, is being referred to. The result is thus a combination of pluralism, equivalence, and referential indeterminacy. So we have here an illustration of what I call a pluralist view, right? So logical pluralism is satisfied as a form of pluralism. Now, does it go all the way to logical relativism, right? So I think the answer here is no. Because here I think incommensurability, which is the crucial additional requirement, does not obtain, right? Because there is a common standard to assess these different logics, right? What follows from them, their set of logical consequences, and how adequate they are to the relevant domain to which they apply. In effect, all of those cases are cases in which you're dealing with applied logic, right? So these are logics used as tools to make sense of inferential devices in a given context. Some logics are going to be adequate to the domain to which they are applied, and others are not. So in the adequacy here involves a match between the logical consequences generated by the logic and the relevant structure of the domain to which you're applying it. So let me give an example to illustrate this. I mentioned earlier quantum logics, right? So an example of non-distributive structures in quantum mechanics, which also gives a really nice example of violation of the distributivity law in classical logic on empirical grounds. So we are all familiar with the distributivity law, right? You have it down there from classical logic. Now, the claim here will be the following. The classical logic is inadequate as a tool to model the inferences about some quantum phenomenon, right? So what we need about, which kind of information about the quantum phenomena do we need, right? We have first the spin principle, which says that E stands for an electron, Y or X will be the position, and you're trying to measure the spin, right? Think, electrons are not little dots, right? But, think of them just for a second like that, right? And they're just sort of, moving around, and you make a measurement, right? And according to the spin principle, when you make a measurement in a given direction, there is only two possibilities. Either the result of the measurement is going to be spin up or spin down, right? So this means the result of the measure in the y direction is up. The result of the measure of the spin of the electron E in the y direction is down, right? That's what the spin principle says. Then you have a version of Heisenberg's uncertainty relations, right? It's not possible to measure simultaneously the spin of an electron in two different directions. So you don't get, so it's not the case that you can measure in x direction and the y direction, right? So you don't get that simultaneously. Okay, now suppose you're in an experimental setup, you sort of separate the system, you make a measurement for the spin in the x direction, and you got an empirical result. It was measured up, right? So let's suppose, for the sake of argument, that's something empirically true of the system, right? Then we can get, on the basis of the spin principle, this is empirically true, and this is true given quantum mechanics, right? Now, apply the distributivity law to this thing. So you're just going to distribute the conjunction over the disjunction, right? And you have the thing on your right. Now let's see what happens with the truth value of these things, right? This is empirically true. This is true according to quantum mechanics. Now, here you have the measurement of the spin of the electron in two different directions. Well, that cannot be true, given the Heisenberg uncertainty relations. This cannot be true either. Then you have the conjunction of true claims is true. You have a disjunction of true false claims is false. And that means then the equivalence here with true and false has been just violated, right? So the thought here is, well, then you have a situation that classical logic, assuming these features about quantum mechanics, would just be the distributivity law of classical logic is just being violated empirically. So it's not adequate to the domain in question. So quantum mechanics, under a particular interpretation here, generates then non-distributive structures, right? Then a non-distributive logic, a quantum logic, would be appropriate for that domain, and a distributive logic would not, right? That's the notion of being adequate for the domain. Now, we do not have incommensurability in this case, since there is a clear standard of adjudication, the very structure of the domain in question, right? The logic didn't get that structure right, so it's out. Right, of course that doesn't mean that quantum logic is the only adequate logic, right? There are different quantum logics that will do the trick. For example, some are consistent, others not. Any of them will be non-distributive. And of course you can always challenge and say, okay, yeah, I don't need an adequate logic, right? I'm willing to make changes elsewhere, right, in the system, and I'm going to stick to classical logic. And of course you can do that, right? You have just to change things elsewhere to keep that. So logical relativism, I think, would not obtain, right? Just logical pluralism. Right. So that's one. So the thought here, okay, as far as logic, fine being pluralist, not okay being relativist. How about mathematics, right? So now, of course, there is a plurality of mathematical structures, right? In set theory, analysis, geometry. And each of them are characterized by suitable comprehension principles, right? Mathematical terms do not have their meaning in their sleeves, right? You need to specify, okay, what are the properties? We have to introduce suitable principles to formulate them. And once you do that, you actually generate a variety of different mathematical structures, right? In set theories, as we all know, some set theories have proper classes, phenomenon Berners-Queteau, others don't, ZF. Some have a universal set, church set theory, most do not. Some are incompatible with the axiom of choice. Quantum foundation is an example. Most are not, right? ZFC, for example. In analysis, we have familiar standard analysis, but we also have non-standard analysis, which has interesting different features. In geometry, of course, we have Euclidean geometry, several known Euclidean geometries, known Paschen geometries, and so on. So you have a plurality of different mathematical structures as part of what mathematics is all about. Now, all of those different mathematical structures, I want to say, are equally adequate within their respective domains, right? To investigate the objects that are posited via the relevant comprehension principles. So the thought would be the following. As species of pure mathematics, they're all equally adequate. Right? You just study them, and often mathematicians study them for that very reason, right? Of course, some may be better suited than others for applications to certain domains of empirical phenomena, right? But this has very little to do with their purely mathematical content, right? It has to do with how you're going to interpret them to make them use in a particular context. So, after all, any such application requires a proper interpretation of the mathematics. And in many cases, you have situations in which you have the same mathematics compatible with very different empirical setups, right? So it's not the mathematics that's doing the work, but how you interpret it. And then that's the insight. So an example is the Dirac, what we now call Dirac equation, right? So it's a differential equation. When he stumbled into that equation, he had negative energy solutions. So in a paper, initial paper, when he came in with that equation, he said, well, we just ignore those negative energy solutions, just as we do in classical mechanics. They don't mean anything, right? 3 years later, he said, no, forget about that. What's going on here is that there are actually holes in the space-time. And that's what those negative energy solutions stand for. And immediately, Weil and Heisenberg pointed out to Dirac, said, look, according to this whole theory, electrons and protons will have the same mass. And that's just empirically wrong. Okay, so scratch that. 2 years after that, he said, okay, forget about the holes. What you're going to do is you're going to think of those negative energy solutions as being corresponding to a new particle that has exactly the same mass as the electron, but the opposite charge. Right? 2 years after that, Anderson, messing up with his experimental apparatus, found something that in retrospect, you can then say, well, evidence for that new particle, right? Which now we call positron. Right? People ask Anderson about, well, did you know about the Dirac theory? And he said, well, I heard of it, but I was so busy messing up with my instruments that as far as I'm concerned, the discovery of the positron was an accident, right? Now, I'm telling you that because often people present that kind of story as a kind of a miracle. They say, well, isn't it amazing that Dirac would discover a new particle out of his office, just making mathematical calculations? Yeah, that would be pretty amazing, right? If that's what will happen, right? So the point is, you have the same mathematical structure, a certain differential equation, with 3 entirely different empirical interpretations. So what actually the crucial work of the physicist is how to interpret the mathematics. Mathematics is the same, right? So we have equivalence from the point of view of pure mathematics, right? Okay. Now, how about referential indeterminacy, right? I think mathematical terms require suitable comprehension principles so that their meaning can be properly specified. Absent these principles, the terms are dramatically referentially indeterminate, right? So you cannot just say, do sets exist? Or how many empty sets are there? Right? The answer is, well, I don't know, depends on what sets you're talking about. Right? And so what do set refer to? Right? Since there are infinitely many non-equivalent set theories, and the extension of the predicate set differs in each of them, one needs to specify the relevant comprehension principles for a particular set theory to determine which sets are at issue. Otherwise, the extension of set is left entirely indeterminate. I think the same point goes through for other mathematical objects, functions, numbers, algebras, and so on. Right? So you do have referential indeterminacy there as a key feature. Now, does that mean that we get mathematical relativism? Right? Again, it depends on what the outcome is with regard to incommensurability, right? I think the answer here is that in one sense it does, we do get mathematical relativism, in another it doesn't. Which sense, right? So I think if you consider mathematics as a pure domain of investigation, there's no common standard evaluation of mathematical structures, right? So as Cantor used to say, mathematics, the nature of mathematics is found in its fundamental freedom. You can explore whatever you want. And in effect, I think the constraints for, as far as mathematicians are concerned, are very minimal, right? They don't want to deal with things that are mathematically intractable, right? So you cannot get anything out of that, nor so trivial that it's so obvious what you get. But anything in between is fair game as far as the practice goes. So in that sense, yeah, I think you do get, from the point of view of pure mathematics, you do get mathematical relativism, right? However, if you consider mathematical structure in the context of applications, then some are better suited to account for certain features of the empirical domain than others, again, given proper interpretation. So in a way here, it's a similar situation as we found in the case of logic, because logic, in the context of applied to some pieces of reasoning, there will be features about the domain that constrains the adequacy of the logic. Here you have the same thing about mathematics, right? As a piece of applied, some mathematical structure will be very good for certain tasks, terrible at others, right? So in that case, you don't get relativism. You get pluralism, but not relativism, because there are standards of evaluation there. So you don't get incommensurability. So we have relativism about pure mathematics, but not about applied mathematics. All right, final part, metaphysical pluralism, right? So here's some questions that metaphysicians may be worried about in the context of the things we've been discussing, right? Are quantum objects individuals or not? Are sets universals or particulars? Are ribosomes structures or not? Right? Now, for each of these and related metaphysical questions about objects, I think there is a plurality of answers. Right? Some are going to be positive, some are going to be negative, some are going to be qualified, some are not. So, for example, quantum objects can be thought of as non-individuals, right? And this simplifies the derivation of the proper quantum statistics. That's one way you can think. Are quantum objects individuals? One interpretation of quantum mechanics, you're going to say, well, no, not really, right? Because you can swap electrons around without changing their state. So, as Weyer said, here's Ike, here's Mike, and there's no way you can talk about an alibi for them. Was Ike the one who did it rather than Mike? Because that presupposes that you're able to somehow individuate the electrons, and you can't, right, according to that interpretation of quantum mechanics. So, and the nice thing about that, you get very straightforwardly the quantum statistics, right? In a way that that is distinct from the classical statistics. Now, but you can also think about quantum objects as individuals, right? In this case, of course, you have to tell some story as to how to obtain the well-supported quantum statistics. So some weirdness is going to show up somewhere in quantum mechanics. Either you upfront say, okay, these objects are known, these things are not individuals, right? Or if you say they are individuals, you have to make some other maneuver to explain how you can get the right theory. So you can think here that we have a form of metaphysical underdetermination. Right? There is pluralism about the answers to those metaphysical questions. And there's no way that quantum theory alone settles the matter in one way or another. Okay, so we have pluralism, right? Now, similarly for sets, you can thought of them as universals, right? And thus as things that can be multiply instantiated. But you can also thought of sets as particulars, right? Located wherever their members are located, and nowhere located if their members have no location. Right? So that's one metaphysical view you may have about sets. Again, nothing in set theory will force you in one way or another. Ribosomes, right? You can, the little cellular structures involved in protein synthesis, right? You can think of them as structures composed of parts that contribute to protein synthesis, right? But they can also be thought as objects that have well-defined boundaries and interact in various ways with other cellular components. So we have here, I think, a plurality of answers to those kinds of metaphysical questions about the nature of objects, right? So you can basically pick and choose whatever piece of metaphysics you want, and you can make it fit to the domain in question. In that sense, you have equipollence, right? The answers to the metaphysical questions are all equally adequate. Some perhaps might be more plausible than others, but none in principle untenable. So it's perhaps not surprising that there is no agreement among the metaphysicians as to how best you answer these questions. Once a framework is specified to determine the content of the questions, right, you have to characterize what you mean by an individual, what the properties of individuals are, or what are the features of universals or structures. Once you characterize that, the answers to the resulting question are easy to get. So this is, in a way, you can think of this as a form of neo-Carnapian metaphysics, right? So you have an introduction, so you need some kind of framework to specify the content of your notions of universals or individuals or structures. Once you specify that, it's a relatively trivial matter to determine whether something is, a certain object is universal or not, right? And so in that sense, it's sort of an easy approach to metaphysics, but with a kind of neo-Pyrrhonian twist, right? In the sense that you're going to suspend judgment, ultimately, right? Because you say, look, you can think about these things, the sets as universal, you can think of them as particular, pick and choose, right? So you're not forced in one way or another to take a decision, right? And so the neo-Pyrrhonist is going to just say, well, I'm going to suspend judgment, right, about that. Finally, about referential indeterminacy, right? I think here there is referential indeterminacy, given that the characterization of metaphysical concepts, such as individuals, universal structures, will depend on the framework that you adopt. And different frameworks will characterize these concepts differently, right? So for example, you may characterize individuals in terms of properties or in terms of spatial-temporal relations or in terms of hexities. Those are different, not necessarily equivalent ways of doing it. And again, it will depend on a particular framework that you're adopting. So in that sense, it's a similar situation as you have in mathematics. Universals also can be characterized in terms of state of affairs, in terms of properties, in terms of tropes, different ways you can go about doing that. Structures can be characterized in terms of set theory, category theory, second-order mereology, or some other combination of those. So each of these formulations can be implemented only in the context of a particular framework, right? And are otherwise indeterminate, right? So now, so we have pluralism. Do we have also relativism about metaphysics, right? Well, that would depend on whether incommensurability obtains or not, right? So, and I think it's unclear how we can in fact choose between the different frameworks, right? Favoring one over the other seems unmotivated, right? So by favoring one framework over the others, one ends up begging the question at some point, or is led to an infinite regress, or simply assume the point without argument. So that's where the neo-Pyrrhonian arguments will come in. And in a way, if you look at just the state of the way the metaphysics is done, you find just that, right? Eventually you run out of things to say, and you say, oh, you're begging the question now against me, right? So often you find these kinds of debates ending there, right? So an illustration would just look at the different ways you can flesh out the notion of an individual, right? Depends ultimately of the kind of assumptions you're going to bring in, right? You may assume that they have some kind of hexity. And so, well, unless there's something that makes this individual what it is, you haven't properly characterized it, right? Or you may adopt a kind of Leibnizian view. Well, an individual, anything that, have all these properties. And if you have maybe some spatial temporal ones, so you can distinguish individuals out of spatial temporal locations. Of course, there are pros and cons. Some might be better for some purposes than others, but those are, in terms of just setting out a conceptual framework, they're perfectly adequate, right? Moreover, metaphysics is typically not constrained by empirical considerations, right? At least on the traditional picture of the subject matter. So with enough ingenuity and sufficient adjustments elsewhere in a framework, it's possible to maintain any of the views about the nature of the objects just discussed. And that's what you find, not surprising, a plurality of different answers to all of those questions. So the result is indeed, I think, a form of metaphysical relativism, right? Someone will say, well, that's the end and goodbye to metaphysics, right? Because we always thought that metaphysics was uncovering the fundamental nature of reality. Now we have all these different ways of cashing it out. Again, it will depend on the particular way you're framing the nature of the metaphysical project. So to conclude, I think relativism doesn't go through unrestrictedly. I think it depends on the domain one considers. So I think in metaphysics it seems unavoidable. You do get these forms of due to incommensurability of metaphysical underdetermination. In mathematics, I think it goes through for pure mathematics, right, but not for applied mathematics. And in logic, it's resisted for the reasons that I mentioned. So pluralism, however, seems apt for all of these domains. So we do have pluralism, I think, all the way down, but we stop short of relativism in logic, short of relativism in applied mathematics, but in full force in pure mathematics and metaphysics. Thank you very much.